A. Is the reaction represented above a redox reaction? Justify your answer. The reaction is a redox reaction because the oxidation numbers of some atoms change during the reaction. Both oxygen and chlorine undergo changes in oxidation number. 1 point is earned for the correct answer along with a valid justification. To better understand, delta H degrees equals delta G degrees plus T delta S degrees equals minus 197 kilojoules per mole of reaction plus 298 Kelvin, 144 J over K times molrxn, 1 kilojoules over 1000 J equals minus 154 kilojoules per mole of reaction. 1 point is earned for the correct calculation of delta H degrees. C. Does the temperature inside the flask increase, decrease, or remain the same as the reaction proceeds? Justify your answer. The temperature increases because the reaction is exothermic, delta H degrees less than 0. 1 point is earned for indicating an increase in temperature with a valid justification. D. Calculate the value of the equilibrium constant, K, for the reaction at 298 Kelvin. Delta G degrees equals RT ln K. ln K equals delta G degrees over RT equals dash minus 197,000 joules per mole over 8.314 J slash moles times K. 298 Kelvin equals 79.5 Kelvin equals e to the power 79.5 is equal to 3 times 10 to the power 34. 1 point is earned for the correct value of K with evidence of calculation. The student decides to produce 40.0 milliliters of O2 at a pressure of 0.988 atmospheres and a temperature of 298 Kelvin using the reaction represented above. The student uses the equipment shown below. The student sets up a 250 milliliters Erlenmeyer flask fitted with a one-hole stopper. The flask is connected to a 50 milliliters gas collection tube that initially is completely filled with water. Visual. E. Calculate the volume of 0.800 molar H₂O₂ that the student should add to excess NaOCl to produce 40.0 milliliters of O2 at 0.988 atmospheres and 298 Kelvin. PV equals nRT. N equals PV over RT equals 0.988 atmospheres, 0.0400 liters, over 0.08206 liters times ATM times moles to the power -1 times K to the power -1, 298 Kelvin, equals 0.00162 moles O2. 0.00162 moles O2 times 1 moles H₂O₂ over 1 moles O2 is equal to 0.00162 moles H₂O₂ needed. 0.00162 moles H₂O₂ times L over 0.800 moles H₂O₂ is equal to 0.00202 liters. 1 point is earned for calculating the number of moles of O2 needed. 1 point is earned for calculating the volume of the H₂O₂ solution that should be added. F. The student added the amount of H₂O₂ calculated in part E to excess NaOCl. However, instead of producing 40.0 milliliters of O2, the volume indicated in the diagram below was produced. Visual. 1. Based on the diagram above, what volume of gas was produced? 2. Assuming that all the gas in the tube is O2, calculate the percent yield of O2. 3. Is the assumption that all the gas in the tube is O2 correct? Explain. 36.5 milliliters. Values within plus or minus 0.4 of 36.5 are acceptable. 1 point is earned for the correct reading of the meniscus level to 3 significant figures. Percent yield equals actual yield over theoretical yield times 100 is equal to 36.5 milliliters over 40.0 milliliters times 100 is equal to 91.3%. 1 point is earned for the correct percent yield. No, the gas also contains water vapor and air that was originally in the flask. 1 point is earned for the correct answer with a valid explanation. Only one of the two extra gases is required for the point. To account for the percent yield being less than 100%, the student claims that the reaction reached equilibrium before the expected amount of O2 was produced. Considering your answer to part D above, do you agree or disagree with the student's claim? Justify your answer. Disagree. The very large value of K implies that the reaction goes essentially to completion, so essentially all of the H₂O₂ reacts to form O2. 1 point is earned for an appropriate conclusion and valid justification based on the value of K in part D.